Hello everyone, so in this video, let us talk about the medium level problem from LeetCode. The problem name is insert greatest common divisor in linked list. So as you can see here that you are given the head of a linked list, pretty much simple here. Now in which each node represent an integer value, that is fine. Between every pair of adjacent nodes, insert a new node which has the value equal to the greater common divisor of them. Greater common divisor is that the number that divides both of them, the largest number which divides both of these numbers. So as you can see that 18 and 6, the largest common number dividing both of them is 6. So in between 6 and 18, you like 18 and 6, you insert 6. Then between 6 and 10, the common divisor is, you can say 2. So you insert between 6 and 10, 2. So now for between every two consecutive nodes, you have to insert a new, you can say node. And then return the head of the original linked list. That's the complete logic. Like actual problem statement. How you can do that? Pretty much simple. In linked list problem, always try to draw out the linked list and then try to visualize it. It's pretty much very simple now. So you have 8, okay, you have 8, then you have 6, then you have 10, then you have 3. So what you'll do is that you have a head here, like the head of the linked list. So you will take the current element and the next element if both of them exist. Then make the GCD of both of them, find out the GCD of both of them. So it's like sorry, 18. The GCD of both of them is 6. Then you will make a new node of value 6. Then make, so it has like this. This is the linked list. So what you'll do is that you will convert this to this, point it to this, and the next one. That's it, that you have inserted a new node. So the next one of the original head you are on, you have to make it to the new node, and the new node next is pointed towards this node. And now you have inserted a new node. So now the adjacent between these two have inserted a node. So now the head should go from here to here, not here. So if you go to head dot next, it will go to here, but that's false. So you have to now make your head go from next to next, which is like here. And then you'll again do a GCD of both of these two numbers, like the current number and the next number. Insert a node between them, like this, that is 2. Remove this link, and then move your head towards the next one, that is this one. Keep on doing that. So you will insert a new node like this between them. So between is 1, and then remove this node connection. And that's it. You have now the new linked list. That's the complete logic of the code part. Sorry, the actual logic part. Let's go to the code part now, how we have done this. So we have to do a while loop because we're iterating with the linked list. We do not know how the end is, but we have to only ensure that the current node that we are on is not a null pointer, and the next one, because both of them should exist. Then only we can find out the GCD of them. So we'll take the two values if both of them exist, then find out the GCD of both the values, the current value, the current head, and the next value head. So head dot next and head value. So which means that the head dot next. So original this and this were adjacent. So both the values we have to find out the GCD using this inbuilt C++ function to find out GCD. Okay, we find out the GCD, and what we'll do is that we'll make our current next. So this head current next is this. Okay, the head next is this, because we have to somehow break this connection. So this is how the connection was, like 18 and 6, and we have to insert a new node. So we have to somehow don't lose this connection. So we'll first store this connection somewhere, that is current next. What is the current next now? Store this connection. Then delete this connection because we have already stored that. Then make this new connection and make this new node next to here. So what we have done is that we have now connected this current head next towards a new linked list. And that new linked list has the value equal to this GCD value. And the next of this linked list is the current next that we have already stored, because we have to somehow store the address of this, because we have to connect like this new node to this node, and that node is address is stored to the next of this. But as we are moving this, we have to somehow store this so that we can point it and match it here as well. So that we have matched. Now we have inserted a new node. As you can see, this is the new character. So we have created a new linked list node. This is this with the value of GCD, which is the GCD of both of them. And the next of it is the current next that is stored this, which is the address of this, so that we are not doing this connection. Now the head has to move from here to here. So if we just move head to next, it will jump to here because now this is the new connection. So we have to move to head to next dot next. So it has to move from here to here so that now the new head will become here. So the new head will come here like this. And now we'll match here the next two, and so on. And we'll keep on doing this until the while loop ends. Now, as you can see, after doing this, my head has moved to the very end of the linked list. But we have to give the very front of the linked list. So what we can do is that we have to, before doing all of this, we have to make a head copy, like a copy of that linked list, so that we have a head copy that even if we iterate over all of this, we have a copy of that. In the end, we'll make my head equal to the head copy and return that. So that we have the copy of the initial pointer from which our linked list has started, so that in the end, when we have done all this like changes, we have the starting the head pointer so that we can return that. We can already like directly return head pointer, but it's better to like make my head equal to that because that's the actual pointer towards the linked list. So yeah, whatever you want. And that's it. That's the only logical code part for this particular problem. If you still have any doubts, you can mention it in the comment box of this particular video. I will see you in the next one. Until then, keep coding and bye.